Good morning again. If this looks very similar to yesterday, it's because I tried to shoot all these videos on Monday when you guys didn't have school, so I could get ahead for once. Kind of feels good. So we have been solving these equations with variables on both sides for 2 days. There is this thing that happens, though, sometimes that we call special cases. So I wanted to go over those with you so that you can kind of see what's going on and, so you can be aware of what those are going to look like. So we're not usually going to know it's going to be a special case, but I'll show you the point when we would and what we're going to do about it. So let's say we had something like 8 times the quantity 4x plus 6 equals, and on the other side we'll have something like 3 times 5 minus plus 10x plus 2x plus 1. All right, so that looks pretty typical of the problems we've been talking about, right? Man, I really write in an angle, don't I? We definitely have some distributed property. It looks like we're going to have some like terms and that stuff. So we're going to go through these just like we would with the rest of the checklist, sorry. So, as you can see, nothing I really want to clean it up. All those are plus signs, so I'm good there. I am going to distribute. So 8 times 4x is 32x. And 8 times 6, 6 times 8 is, why can't I think 6 and 8 went on a date. They came back as 48, obviously. And then on the other side, I only want to distribute the 3 to the stuff inside the parentheses. So 3 times 5 is 15. And 3 times 10x is 30x. And then this stuff's just going to stay the same, right? So that's what it would look like after the distributed property. And then I'm going to check. No like terms over here. Yes, like terms over here. 30x and 2x. Those will give me 32x. 1 and 15, when I add those together, are going to give me 16. Oops. And then on this side, this stuff just stays the same. So everything looks normal so far, blah, blah, blah. And then I see I have variables on both sides, so I'm going to get rid of this 32x. So that means I need to minus 32x. But when I minus 32x on this side, it also cancels out. That is where we're going to find our special cases. So what you're going to find is that sometimes when I get rid of an x on one side, it's also going to get rid of the x on the other side. And that can trigger 2 special cases we're going to talk about. To figure out which one it is, we need to look at what we have left. So over here on this left side, we have 48. Over here on this right side, we have 16. Now, I'm no doctor, but I don't think that 48 equals 16, right? That's not true. So if this statement right here is a false statement, right? Maybe it says 2 equals 3. Whatever it is, then our answer here is no solution. No solution. All right, you can write out the words no solution, or there's a little symbol you can use, which is a 0 with a line from the top right to the bottom left. Either one is going to be fine with me. No solution literally means there is no number that exists that you could plug in for x that would make this side of the equation the same as that side of the equation. It just doesn't exist. And later on in the year when we talk about systems of equations, we're going to talk about why that actually makes sense. But for now, there's just no x that would make these 2 things equal. That means that we're going to write no solution. Let me give you the quick recaps again. We solved it like normal. Our variables canceled out on both sides. That's the key. I looked and I had a false statement, that means no solution. Cool. What about the other special case? Well, I'm so glad that you asked. The other special case is going to look like this. Let's say I have 4x plus 9 minus 7x plus 3 equals 3 times the quantity 4 minus x. All right, again, nothing really gives it away when you start the problem. You're not like, oh, I can see it's going to be special. A lot of times they're not going to be a special case. Like tomorrow, I'm just going to give you more practice and they're just going to be mixed in there. So you're not going to know. You're just going to only know when you start solving these things and see what happens. So I'm going to go through my checklist again. Anything I want to clean up? Yeah, a little bit. I don't like these minus signs. That's negative 7x. I'm going to throw a 1 in front of here so I know it's negative 1x. And then, do I need to distribute? Yeah, I do. So also notice, math students, I am not doing more than one step in a line. You shouldn't be either. Okay, there's just no reason for that. You're going to lose yourself, and you're definitely going to lose whoever you're trying to show that you know what you're doing, which is me. I want to see that you know this is the order that I do my step in. This is my step. Here's what I got. Now I'll do the next step. So be really careful about that, because when this test comes around, I'm going to be very particular at what you showed me is going to give you how many points you're going to get. So 3 times 4 is going to give me 12. And 3 times negative 1x is going to be negative 3x. So I distributed, I got to here. Now I'm going to check like terms. Well, over here, there are no like terms. Over here, there are like terms. I got a 4x, and I got a negative 7x. Those go together, give me negative 3x. I got a 9, I got a 3. When I add those together, I get 12. So that's what happens after I add my like terms. And you might be saying, hey, Mr. Rody, I see something that looks a little fishy. Yeah, well, let's see what happens if we keep going. Now I notice I have variables on both sides. I want to get rid of one of them. So I'm going to go ahead and get rid of this negative 3x. That means I need to add 3x. When I add 3x to this side, they cancel out. But when I add 3x to this side, they also cancel out. Hey, 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 special case. A little alarm should be going off in your head. I look at what I have left this time. Well, by golly, 12 certainly does equal 12. So this time, I am left with this true statement, right? This is true. 12 does, in fact, equal 12. So if I'm left with a true statement, then my answer, my special case, is infinite solutions. Or all real numbers. You can write either one. Depending on the level of math you're in, they'll both be correct. It is not, the answer is not infinity, so don't get confused by that. This just means infinite solutions. What that means is that no matter what number I pick to plug in for x in this one, it will always give me the same thing on both sides, which is pretty crazy. So if I pick 2, it's going to be equal to each other. If I pick 5, it's going to be equal to each other. If I pick 7, they're going to be equal to each other. So that's kind of nuts. But that is one of our other special case. If these answers were false, no solution. But if they're the same, if that's a true statement, it's infinite solutions or all real numbers that will work in this equation. All right, those are the only 2 special cases that are new. It's kind of weird, so you got to be really careful with these ones, all right? Go ahead and try the practice. If you get stuck, definitely watch the video again. This is a short one. I kept it short. Just wanted to show you those two cases. And then let me know if you have any questions. All right? You guys have a great rest of your day.